Hello, everyone. Thanks for giving this opportunity to present my paper. So, the title of the paper is Smart Charging of Electric Vehicles at Residence under Different Tariff Regimes and Meter Configurations. So, I am Pradeep Yemula, and my co author is Mr. Keerthi Balaram Javvadhi. So, let's get into the presentation. So the background and motivation is the electric vehicle adoption is on the rise. So this is known to everyone, and lack of extensive public charging infrastructure as of now. That is another problem, and fast charging equipment is too expensive for individual use. So finally, because of these points one, two, three, the EV owners are resorting to charging at residence, when to charge, how to charge, and how to reduce the electricity bill. So these are the questions that comes in the mind of the EV owner. Now, what is the solution approach? First, we examine the tariff structures. So since we belong to India, so we have taken the tariff structure called slab rate tariff and time of the day tariff, and then metering configurations, that is single meter, multiple meters, and control charging. So based on this, we'd like to propose a solution. So first, let's just get a quick idea about what is slab rate tariff. So on the left, you can see 0 to 100 units. So this is a monthly consumption of energy, and 101 to 300, 301 to 500, and so on like this. So the first column shows the amount of your consumption, and what is a fixed charge, and what is a wheeling charge, and what is the energy charge for this particular slabs. So that is provided. So the source of this tariff structure is MSC which is a discom in the state of Maharashtra, India. So, as a simple example, if your monthly consumption is 380 units, say. So, if it is 380 units, then it falls under the slab of 301 to 500. So, first we add 65, then we had 100 units at the rate of 3.07, and 200 units at this rate, and so on. So, like this. Finally, the bill will be calculated to be some amount like this. So now tariff regimes. So what are the tariff regimes? So this is another TOD tariff. See, the slab tariff and TOD tariff are different. So we examine these two options. In the time of the day tariff, until morning 6 a.m., the tariff is 7.1 rupees per kilowatt hour. Then 6 a.m. to 9 a.m., the tariff increases because this is a morning peak. Then the afternoon, the tariff reduces to 8.6. But again, in the evening peak, which is the tariff jumps to 9.7, and again in the night the tariff continues at 7.1. So this is like a sample time of the day. Depending on the time of the 24 hours, the tariff keeps varying. So under these two tariff regimes, how to charge your electric vehicle. So here we discuss four options. Option 1 and option 2 come under slab rate tariff. So in the option 1, a common meter is there which is supplying to the house, and the same meter is supplying to the electric vehicle. So this is the default option. People who purchase electric vehicle and do their domestic, residential or home charging, they do like this. See, as a result of option 1, what happens is your home consumption may be X and your electric vehicle consumption may be Y. Then X plus Y, total amount, the number of units will be more on this single meter, and you will push to a higher slab. And if you notice, as you increase the slab, the price is increasing from 3 rupees almost up to 12 rupees. So, this option 1, may become more costlier. So to avoid that, option 2, we install a separate meter, we take a separate connection, and then we connect the electric vehicle from there. This is under slab rate tariff. In the time of the day tariff, the home still gets the same connection from the regular meter, but for the EV charging, we resort to a smart meter and with a TOD tariff. So depending on at the time when the tariff is low, you can charge the vehicle and get more benefit. And finally, option 4 gives the maximum benefit, where we have a separate meter for EV with a fuzzy logic controller, which basically controls the rate of charging, so that your bill is further reduced. So these four options have been simulated and bill calculations are made, and the comparison is made for a typical usage. So let's continue. Since the first three options are straightforward, directly I'm discussing option 4, the control charge controller design. So from the smart meter, I get the power and for the controller, and then the TOD tariff and the state of charge of the electric vehicle. So these two forms the input for the fuzzy logic controller. Based on that, the rate of charging is controlled, and the charging socket controls the EV, and finally the battery gets charged. So this is the simple structure. So a simple fuzzy logic controller with two inputs, TOD tariff and SOC, and one output, rate of charging. Again, you can see the rules being implemented. So on the x-axis down, you can see input parameters. One is the state of charge and the other is the time of the day tariff. Whereas on the y-axis, we can see the charging rate in percentage. So for example, you can see this blue colored part. This blue color area, what it shows is that when the time of the day tariff is high and when the state of the charge is also high, then the charging rate is almost zero. We should not charge at that time. So as we move higher, for example, when the tariff is low and when the state of the charge is low, then we go for higher charging rates. So by controlling the charging rate through the surface, the fuzzy logic controller operates and thereby tries to reduce the electricity bill. So in the interest of time, let me jump directly to the results. So what we have here is a comparison of electricity bill for 1 month, and all the values that you see in the numbers are in Indian rupees. And here, assuming that the electric vehicle will be traveling 50 kilometers per day. So, if your electric vehicle carrying traveling 50 kilometers per day, accordingly, number of units required to charge is calculated, and according to that, the electricity bill is calculated. Now, the each row indicates the start of charging. So whether you want to charge your vehicle in the morning, early morning charging, or the late night charging, or whatever different times, afternoon charging, or in the peak time charging. So accordingly, now if you see the slab rate tariff, there is no sensitivity to the time of the day, but the you see the decreasing trend from option 1 to option 2 to option 3 to option 4. As you move towards right, your electricity bill is reducing. So for example, in this case, the best result comes when uh, when you charge during night time. Okay, so that is 3098 rupees, whereas the regular bill used to be 3800 rupees. So this is a significant, almost 20 to 25% reduction in your electricity bill just by using this different schemes. Similar result for 100 kilometers per day consumption. Option 1, option 2, option 3, and option 4 are compared. And in the option 1, the electricity bill adds to 5,600 rupees per month. Whereas if you use the proper option, it can go as low as 4,065 rupees per month. So different options and different charging times and all these things is mentioned here. So finally, we can see how the electricity bill can be reduced as much as 20 to 25% in the by using these methods. So again, let me refer back to my background and motivation slide. So I was mentioning that EV owners have to resort to charging at residence. So for the residential charging, when to charge, how to charge, and how to reduce electricity bill. These were the motivation questions, and accordingly, the solution approach what I mentioned, depending on the slab rate tariff and depending on the time of the day tariff and different meter configurations, the proposal now is to go for a charged controller. So let's conclude by making these final recommendations. First, for EV users, so take a separate connection for EV at residence. So don't use your regular meter that you already have connection. You have to take a separate connection for EV so that you don't jump into a higher slab and pay more. Similarly, install a smart meter and have a charge controller also. So don't go for regular charging, but having a charge controller at home. Now, the fast charging controller available outside is very expensive, whereas this kind of a simple fuzzy logic controller is both cheaper and it also does the work. Now, recommendations for regulators and policymakers. First is spread awareness about methods to reduce the bill and introduce time of the day tariff and facilitate electric vehicles to be charged at the time of the day tariff. So this is for recommendations for regulators. And for utilities, utilities can offer attractive tariff schemes for EV charging at home. See, normally utilities complain that we are not able to identify or recognize the EV demand. But here, by incorporating a separate meter for EV, utilities can get directly the data of only EV charging, and therefore they can offer attractive tariff schemes. And similarly, they can implement demand response for EVs at home. So that's it for my presentation. I hope this presentation was interesting and useful. If you have any questions, feel free to contact me at my email ID ypradeep@ee.ith.ac.in, which is there on the slide. Thank you so much.